Okay, so in this video, we're going to be looking at some examples of how to write the equation of a polynomial with some given properties. Now, sometimes these problems will also specify the degree of the polynomial, so that they can be a little less explicit about information like the multiplicities and things like that, particularly when they're assumed to be one. But in this case, we're just going to state out the multiplicities, and we have an additional property that we have to satisfy for this particular function. All right, so these are all real zeros. So this is going to be the simplest scenario we possibly can have. And we're simply going to write out the factors for our polynomial in factored form. So if there's a 0 at -3, then the factor is going to be x plus 3, because if I set that equal to 0, I get x equals -3. There is no power to this expression because it's multiplicity 1. 0 has a multiplicity of 2, so the factor that gives us 0 as a 0 for our polynomial is x. This has multiplicity 2, so it's x squared. And then finally, we have 2, x minus 2 is the factor, but this has multiplicity 3, and so we would write it like this. And so if we rewrite this sort of in more standard canonical order, x plus 3, x minus 2 cubed, what we then want to do is we want to then find any potential scaling factor. Now that's something that, again, it could affect the end behavior depending on whether it's positive or negative. But here we're given 1 point that we want it to pass through. And so that's actually going to determine what that a has to be. Now, you don't have to multiply this out in order to get the a, but there are often circumstances where you will be asked to multiply everything out and FOIL it. But let's find a before we try to do that. So f of 1, or p of 1, in this case, we want to be -6. So we're going to plug 1 in everywhere. And we're going to find out what it is without the a. So a times 1 times 4 times -1 cubed, which is going to give me -1 cubed is just going to be -1. So this is going to be -4a. Now, I now know that -4a is equal to -6. And so from that, I can determine that a must be equal to 3/2 when I solve for a. So my final equation is going to be 3/2 x squared, x plus 3, x minus 2 cubed. And again, I can multiply this out if I wanted to. The tricky part is going to be the x minus 2 cubed. This is going to become x cubed minus 6x squared plus 6x minus 8. And then I will have to FOIL through we'll do the 3/2 x squared last, of course. X times x cubed is x to the 4th. X times -6x squared is -6x cubed. X times 6x is 6x squared. X times -8. And then 3 times x cubed and 3 times -6x squared. And then 3 times 6x, and then 3 times 8, positive 3 times -8. Then again, before we do the last bit, we'll simplify cubes. negative 24x cubed. Nope, this one is a square. Let's try again. Negative 6 plus 1 is negative 5. Positive 6 minus 18 is minus 12x squared. And then one should be a negative 8x. Negative 8 and positive 18 is going to be plus 10x minus 24. And so finally, we're going to get 3/2 x squared times x to the 4th is x to the 6th. And then minus 15 over 2x to the 5th minus 2 cancels with the 12, leaves me with the 6. So I get 18x squared plus 30 over 2, which is going to give me 15x minus 36. Now, again, personally, I usually only require students to get to all real coefficients. So I would be fine with students leaving it this way. It's only the complex zeros that I want people to multiply out. But again, this may differ from instructor to instructor, and so you may be asked to multiply it out entirely. Now let's look at an example that has complex zeros. So let's say I have zeros at negative 2 with multiplicity 3 again. A 0 at and then multiplicity 1 at negative 1 and 2 plus 3i, and f of 0 is 24. Now, the thing to keep in mind anytime you have a complex zero is that complex zeros, if you have real coefficients, which is the universe we're living in, you have to have pairs of complex zeros, and they have to be conjugate pairs. So the fact that they've only specified one of them does not mean the other one is not there. It just means you also have to include it. They don't have to list it because it follows as a consequence of the fundamental theorem of algebra. So we're going to start with our factored form. So 0 at negative 2, so that'll be x plus 2, multiplicity 3, and then a multiplicity 1 at negative 1. And then also we have x minus 2 plus 3i and x minus 2 minus 3i. Again, in factored form, it's x minus the 0. Now, once we have this much, then what we can do is we need at a minimum, again, even for me, I don't want you to leave these complex numbers here. You have to at least turn this into an unfactorable quadratic. So I'm going to multiply out these first, and then we would have coefficient factored form with all real coefficients. And for myself, I would be happy for you to stop there, but then again, depending on the instructor, they may want you to multiply them out all the way, and then we will finish that job. It's a little tedious because of the cube, but it's fine. So the complex portion that we're going to work on first is x minus 2 minus 3i by distributing the minus sign, and then x minus 2 plus 3i, again, distributing the minus sign. And then we FOIL methodically. X times x is x squared. X times negative 2 is negative 2x. X times 3i is 3ix. And then minus 2 times everything, so minus 2x. minus 2 times minus 2 is plus 4. Minus 2 times 3i is minus 6i. And then minus 3i times x is minus 3ix. And minus 3 times minus 2 is going to be plus 6i. And then minus 3i times positive 3i is minus 9i squared, which of course I squared should be replaced with minus 1. But what you'll see here is that all of the I terms cancel. Here's a negative 3ix and positive 3ix, and negative 6i and positive 6i. And then when I replace this with minus 1, then I will have only real coefficients, minus 4x, and then plus 4, and minus 9 times minus 1 is going to be plus 9. 9 and 4 is 13. And so we saw an example of the cubic thing in the previous problem. But basically, it's x cubed. Actually, come to think of it, I may have had an arithmetic error when I was doing the cubing. This one should be 12. And this one should be then 36. Yeah, because it's if this is a plus b, then this is a plus b, then this is a cubed and 3a squared b and 3ab squared, and that 2 has to go in there twice. Okay, so then fixing my arithmetic, the square is what was affected. Oh, not that one. That one was okay. It was this one. So the squares become negative 6. And so this becomes 9. And 36 and 8. This won't be 10. It'll be 24. And so this will also be 36. All right, so x cubed plus 3 times 2, which is 6, x squared plus 3 times 2 squared is 12x, and then 2 cubed is 8. And so we've got this times x plus 1 and x squared minus 4x plus 13. And now we need to FOIL through something. So let's do our 2 smaller ones first. So x times x squared is x cubed, and x times negative 4x is negative 4x squared, and x times 13 is 13x, and 1 times x squared is x squared, and 1 times negative 4x is negative 4x, and 1 times 13 is 13. And if we simplify, x cubed minus 3x squared plus 9x plus 13. And then we FOIL one more time. So x cubed times x cubed times x 3x squared, x cubed times 9x, x cubed times 13, 6x squared times x cubed, and 6x squared times negative 3x squared, and x squared times 9x. Oops. And then x squared, 6x squared times 13. $78 x squared. And then 12x times 3x cubed is 12x to the fourth. And 12x times minus 3x squared is negative 36x to the cube. And 12x times 9x, 12 times 9 is 108 x squared, and 12 times 13 is 156. This is why we usually don't multiply it out all the time, all the way. And then 8x cubed minus 24x squared plus 72x, and 8 times 13 is 104. And if we try to combine like terms, we have x to the sixth. Here is our 2x to the fifth, so minus 3x to the fifth. And then here's a fourth, so that's a 9. And here's a minus 18. And here's a 12. And that gets me plus 3x to the fourth. And then here's a cube. And here's another cube. And here's another cube. And here's another cube. And so I end up with 39x cubed. And then my squares, we've got a 78 and a 108 and a minus 24. And that gets me 162x squared. And then my x's, 156 plus 72 is 228x, and then 104. That is my multiplied out form. Now, we also had one additional property that we wanted to worry about, which is that f of 0 is 24. Now, in this multiplied out form, that's actually going to help a little bit because if p of 0 is 24, our current polynomial is actually 104. So what we need is, again, multiply everything here by a. And so what we know then is that a times 104 is equal to 24. And so our scaling factor is going to have to be 24 divided by 104 is going to be 3 out of 13. And so our final polynomial is going to be 3 out of 13, x to the sixth minus 9 out of 13 x to the fifth plus 9 out of 13 x to the fourth plus the 13 cancels with 39 and leaves you with 9x cubed. 162 times 3 does not divide by 13, plus 486 over 13x squared. So 228 does not also divide by 13. So I'm left with 684 over 13x and this should be 24 plus 24, or we could leave it in, again, factored form. What were our factors? X plus 2 cubed, x plus 1, and x squared minus 4x plus 13. Either of these are valid algebraically equivalent answers, assuming I didn't lose a minus sign someplace.